Welcome to the machine shop. Remember, when you're in the shop, you always need to have your safety glasses and be wearing steel-toed boots. My name is Caroline, and I'm going to go over a brief introduction of the vertical mill. And this is a manual mill, and this is just a general introduction to explain all these levers and these buttons. First of all, the most important thing is safety. So you need to know where the emergency stop button is, which is right here. We'll always keep that handy. And also I need to know where to turn the machine on and off. Of course, I'm always going to turn into the forward position, at least for now. Later on we'll look at tricks. If the spindle is not rotating clockwise, we may have to go into the reverse position. If I want to turn the machine on, I'm going to make sure that there's nothing in the way of my vise, that nothing is going to interfere. I'm just going to move some of these tools over and turn this on and show you how to turn the machine on and then off. When I push in the button into the forward position, you'll notice the spindle starts turning. If I want to turn the machine off, I flip it to off and I hit the brake. You'll notice I'm also not wearing any rings or any watches. We always take jewelry and put that in our pockets for safekeeping. What I want to talk about now is some of the terminology with regards to loading a part in the vise. I want to mill a part, mill a face flat, and so we have to use the vise wrench to tighten the jaws to hold our part in. I also have a stop that is already set in place where I want it. I'll be using a set of parallels, and these parallels are nice and clean. I load them in the vise here, and those parallels are going to hold my part flat in the vise. So if I didn't use the parallels, perhaps it would be easy for me to, when I'm loading the vise up, and I got to open it all the way. If I didn't use parallels at all, I could certainly hold that crooked. So the parallels hold the part flat in the vise. And also, another thing I want to make sure of is, right now I have two rough edges. We're going to look at the size that we want. I have to make sure I load this the correct way. Another thing is, if you're looking for parallels, you'll find over here in the cupboard, we have a full set here. They're all labeled and they're all clean. So make sure you clean off the parallels and put them back when you're done, so when you need them again, you'll know where to find them. Coming back over here, I have my parallels already in place. Another thing I'm going to use is called a parallel holder. These are not parallels. They're spring-loaded, so you want to be careful you don't let it go while you're holding it tight. Place it in, and then I'm going to let that go, and that's going to hold my parallels in place, and I make sure my parallels are pressed down. Some more terminology. What I have here is a cutter. So I've got a 4-flute end mill. I'm going to use that cutter to machine a flat surface on this edge. I also have a collet. The collet matches the end mill. That goes together. We also have a whole load of collets over here in our case. We make sure when we select the collets that we put them back when we're done. There's a dedicated set for each mill that we have. When I'm loading the tool into the collet holder, what I want to do is do this in a particular order. So I have a nut. I've got to place the collet on an angle and snap that in place. Now I can put the 4-flute end mill in. I place that in, and then I'll tighten this nut up, holding the tool at all times. If I drop the tool and it falls on a hard surface, I will damage it, and that's an expensive thing to do. So we'll try to protect the tool at all times. Another thing you should note is I want to engage this fully, so I'm not going to leave this hanging out. I'm going to engage that fully. That makes for a rigid setup. These tools are sharp, so be careful. You don't want to cut yourself. We want to, again, think of safety first. Loading the collet holder into the spindle. Now this is a little bit tricky. What you need to do is make sure these dogs are going to line up in the slot. Okay? The other thing I need to do besides lining up the dogs, and I can turn this to position, turn the spindle to make sure I line the dogs up correctly. Another thing I want to do before I even go there is I want to make sure my spindle is fully retracted. This is the spindle lock, so if I loosen this up, I need to pull this handle out, loosen it up again. I can raise and lower my spindle. Now I'm not going to be using the spindle, so I want to make sure it's fully up. I'm going to bring the lock, tighten it up, bring it down, and keep tightening it until you can't tighten it anymore, because what we have is a hydraulic loading cylinder, and this will bring your collet holder in and out. So I have to make sure the spindle's locked in order for this to work properly. Now, when I'm loading it, think of safety. Never have your fingers in the way. Always hold down by the nut. I'm going to eyeball, basically guess, that I think these are lined up. And I'm going to slowly press in. So watch as I do that. And you can see it popped into position, and I'm going to give that another, I'm going to feed that again to make sure that's locked in. Another thing I have to do is lock that nut. Remember, the nut is not yet locked. If I'm going to lock this, I need to use a brake. Okay, so this is the handbrake. I'm going to pull down on the handbrake, and then I'm going to lock that nut nice and tight. Now I have a rigid setup. I can place my wrench on the table as long as that's not in my way. I have a rigid setup. Let's just review turning the machine off and on and then stopping it again, just for safety's sake. I turn it on. Notice when I stop, I switch to off, and I'll pull the handbrake right away. Let's make sure you can see that the cutter is turning in a clockwise direction. Just watch as that slows down. Now if I wanted to change my speeds, up here I have high and low for the spindle speed. We're not concerned with speeds right now, but just watch. If I want to go into a faster mode, I would be in high. And you'll see also on the side, we'll look at whether we're in high or low in a second. Let's just turn this on, and I will speed up while the machine is on. That's how I would change my spindle speeds. For now, I'm going to leave this at about, we'll say 1800. I turn it off, and I stop it. If you look around the side here on the machine, you can see that I have a high, neutral, and a low position. Again, if I was machining in low, I would flip this switch while turning the spindle, and then I'm in the low position. Now, that means I'm now in reverse. So that's what you have to watch. If you're ever machining in low, watch when I turn this on in forward. You'll notice I'm going backwards now. So the trick of this machine is remembering that I would have to be going in reverse. That's a bit extra, so don't worry about that for now. For now, we'll stay in the high position, and that's all good. Now, let's look at the drawing. So here's a drawing. Let's say I have a part. In this case, it happens to be a cylinder plate for the Stirling engine. And this is the dimension that I'm concerned with, specifically the height. It's 2.5 inches. If you'll look at the tolerances, it says for fractional dimensions, plus or minus 1/64th, which is about 15th thou, or half a millimeter. Here's my part. What I've done here is I've already set my caliper up to 2.5, plus or minus a hair. So I've come out, I've set my caliper, and I'll do that again. I'll zero it. I'll bring this out. I want it to go to, or I want to set it up at 2.5. So I set it up to 2.5 plus or minus a hair. I can zero this, don't turn it off, zero it. And I know 2.5 or 2.5 inches is the dimension I want. Now here's my part. So if I measure this, let's see how much oversize it is. It's 160 thou oversize, or if you care to know in millimeter, about 4 millimeters oversize. I'm going to work in inch for now. 160 oversize, that means I want to take about half of that distance off the top. Later we'll take something off the bottom. In this case, half of 160 is about 80 thou. Now I'm going to load this in the vise, hold it rigidly, and take off 80 thou using the digital readout. And perhaps before doing that, I should introduce the axis of the machine to you. What you have here is you have 3 different ways to move the tables. Okay, so if I want to move the knee up and down, I can do that by hand. And it's recommended when you're a beginner, you're just using the machine for the first time, that you use these hand wheels as opposed to the automatic feed. There is automatic feed on the machine, so I can raise and lower this. I can adjust my speed, so raise or lower the machine. But for now, I recommend that you use the hand wheel. So that's for the Z direction. If I want to move in the Y direction, I can make sure all of my locks are off. In this case, that's the lock for the Y direction. And I can feed in or out. So that's Y. For X direction, what I want to do is, again, with the hand wheel, I made sure my locks were not on. I don't want to force the machine when it's in the locked position. And this is my X. I can also use the auto feed. Of course, I made sure that I wasn't going to crash the tool into the vise. That's very easy to do. You'll notice when I turn my hand wheels that there's a digital readout, and the digital readout is moving in a negative or positive direction depending on which way you move the part. What I want to do now is set up my part and take off about 60 thou of an inch off the part. So I'm going to load this in, set it down on the parallels, and what I'm doing is two things at once. I'm pulling the part towards the stop while pushing down. I put the wrench in, the vice wrench in, and I'm going to make sure I'm pulling it towards the stop while pushing down. I take this out and I readjust it so I can really tighten this up. So I'm going to really give that a good tight. I want this to be rigid when I'm machining it. Now I'm going to bring the cutter over, just manually. Bring this over until I'm fairly close. And I want to make sure the direction that I actually machine this part is by pulling the part against the cutter so that the teeth are digging in. That is called conventional milling. In this case, I'm just going to eyeball this and bring this up fairly close. Now, in order to take 80 thou off this part, there are many ways of finding your edge. I'm going to show you a simple method, which is we turn the machine on, and when we've just slightly grazed the edge, I'm going to push the part away from the cutter and set my zero. So, I've got a rigid setup. I turn this on, and I'm going to slowly pull the part into the cutter. You'll probably hear it before you see it. Just slowly approach. And I can hear that I just touched it. I probably took off about 5 thou, but we're not going to worry about that. The other thing I want to do is set the digital readout on the x-axis. In order to do that, all I need to do is hold the button on X, and it zeroes that for me. The next thing I want to do, I said 80. I want to take 80 thou off. So I'm going to pull the part in while the x-axis then reads 80. And again, I don't have to be too accurate for now. I can keep it exactly at 80. That's what I want, but it could have been plus or minus a few thou. Another thing I'm going to do is suggest you lock the axis for the X direction. If somebody comes by and bumps into the table, nothing's going to move. We will also need some cutting fluid. We're going to be using green cutting fluid. We're going to be using aluminum cutting fluid and a brush. I want to make sure if I'm going to be brushing some oil on this that I don't touch the cutter while it's moving, so I'll keep the brush well away from the cutter. It could pull my hand in and I don't want that. I'm now ready to machine. When I feed, I'm going to make sure I feed in a consistent fashion. Flat, completely, machine, and then I'll bring this back so I'm ready to do another piece if I had more to do. I want to turn this off now, so I reach to the off position and pull the brake. I can visually inspect that, see if I'm happy with it, and then take the part out. We've now machined one side of this part. We could deburr that. There's a lot of sharp edges on that. Let's measure it to see how much is left over. Remember, my finish dimension is 2.5. I want to hope I didn't take too much off. I still have 75 thou to take off this part, which will be done at a later date. In this case, where we'll be turning this part into this on the CNC mill. And for your information, what does the difference look like? This was cut on the cold saw, and this was machined using the 4-flute end mill. And that's it. That's the general introduction for the manual mill. Thanks, and see you next time.